So we are actually constrained by the law about how we're able to fly these. So a question we often get asked is how high these can fly. We're only legally allowed to go to 120 metres. There's also other regulations, like we're not allowed to fly within 5.5 kilometres of an airport. And there's a few other areas where we're not allowed to fly, such as national parks. We also have to keep 30 metres away from people and buildings if they're not directly involved. So if I was directly flying and I had my buddy Luke spotting for me, then we're able to be within 30 metres. If a passerby is coming through, we have to maintain a 30-metre gap. So they're the main rules that we actually have to abide by. The other one is we always have to be able to know which direction the drone is facing whenever we're flying around, so that we're not able to lose control.
So I've got a question for you, Nick, on that. I don't know if everyone can see me behind there. So we know there's some rules about we want to fly our drone. What's the fastest and what's the easiest way to look at an area and know if I can fly my drone there?
Great question. The Civil Aviation Safety Authority, also known as CASA, has put out a really, really good app called Open Sky. And what it does is it takes your location on your phone, drop a pin, and it will show you all of the restrictions and also along with all the regulations that are involved with it. So it will tell you right then and there whether you can fly that, because there might be some airports that you don't know about. So before you go out flying anywhere or before you start to fly, I'd highly recommend checking out that app and making sure that you are legally allowed to fly there. The other big one is we're not actually allowed to fly at night either, because we can't be able to tell which way the drone's facing if we're flying at night. That help?
Cool.
Hope that answers your question. Now I'll pass over to Luke to tell a bit more about what these drones do.
All right, thanks, Nick. So as promised, this is a whiteboard session. So like all good engineers, we can do diagrams, but we can't draw very well. What I'm going to do is basically sum up everything Nick just showed you on the drone, on the whiteboard. Now, I'm going to actually explain some of these acronyms that we use as well, because you'll see those quite frequently online. So to start with, so we have our operator here. Let's call that me today. I'm holding my transmitter, so that's my remote that you saw before. That's typically called your TX, so TX for transmit. And what that's doing is that's providing a signal up this line here into our drone. Now, on board our drone, we have our receiver. That's what we call RX. The receiver takes all the signals continuously from that controller, and that pushes that into our FC. So our FC is our flight controller that you would have seen before from Nick. That flight controller, that's your brains of the quad. Every quad will have one of those. That flight controller then takes signals from your transmitter, say your stick movements going left, right, throttle down, throttle up, and that talks to your electronic speed controller, which then in turn talks to each one of your motors. So I guess when you're looking at how does that signal interaction work, that's basically how we get a signal from your stick movements on your transmitter to your receiver, to your flight controller, through your speed controller, which tunes those controls how the motors would like to see it, and that responds with a change in direction and speed of those motors. For the video side of things, it's very similar, and it's very simple. Your camera at all times, provided it's powered, is taking a signal. That camera is then actually providing that signal back into your brain, back into your FC. Your FC then takes that signal, does a bit of processing on it, and provides that out to your VTX. So yes, another acronym. So VTX is, if you didn't guess already, that's video transmission or video transmitter. And that VTX quite simply takes that signal and pushes it out the back a video antenna. So the back of your quad will push out that video signal, and that effectively broadcasts that analog signal outwards. That analog signal, you could then imagine it going everywhere, but if you follow the line, it goes back around, back to the operator, to the goggles that you saw before. So really simple diagram, just quick 30-second draw. That's part of being an engineer, is putting together really fast diagrams like that. And that, I guess, diagrammatically explains how this all works. And that probably sums up our session, I think. Any closing comments from you, Nick?
Just one final one. Our very astute viewers will notice that I forgot to mention anything about propellers. Now, these are pretty important if you want to be able to fly, because you've got to push air down. So these are taking that electrical motion from the motors and transferring that into thrust for us. So to give a bit of an idea of what these propellers are capable of, they're putting down about 500 grams of thrust each, and this drone with a battery weighs about 500 grams. So one of these motors theoretically could lift the drone, but we decided we want 4 of them so it can go quicker. So your big things with your propellers is, first of all, how many blades you have per motor. So the sweet spot for most racing is 3. And as a general rule, the less blades you have, the better top speed you have. So if I put this down to 2 blade, we might be able to squeeze 170 kilometers an hour out of it. But the downside to that is that you don't get that same acceleration. And when we're zipping around a course, like you'll see later on, we want that acceleration. We want to be able to change movement and punch out. Some other people have actually moved to 4 blade because on smaller, tighter tracks, we want that acceleration even more. We want to be able to grip the air really, really well. Some other considerations is the size. So I mentioned that most people run 5-inch. Some people run slightly larger, so 5.1, or slightly smaller, 4.8. And so slightly larger will give you a little bit more thrust, but the slightly smaller will have less interference between the two. So you notice that the gap there between the 2 propellers, I'll put my hand behind so you can see, is actually, it's pretty small. So if we had a slightly smaller propeller there, then you wouldn't have the air interfering with each other, and it'll be much, much cleaner air that's going to the propellers. The other big one is what we call pitch. So that is how steep of an angle that these blades are on. So this one here, because it's a racing drone, is quite an aggressive pitch. So if you imagine, really shallow pitch is like that, and really aggressive is like that. So you're able to push a lot more air with a really, really aggressive pitch. But the downside to that is you're working your motor really, really hard. So if you actually put too high of a pitch on a propeller, the motor can catch fire, which I have seen before. Luckily, I haven't done it personally, but I have seen it done before. And this all draws back into the design considerations of it. So you have to know what your motor is capable of in order to put the right propeller on it that feels right for your style and the equipment that you have. And I believe we have another question.
Yes, we do. So, what we've learned here, great question. So we've learned some great stuff about the motors, ESCs, and flight control, and just drone racing in general. But how does this actually relate back to your job as an electrical engineer? Potentially some informal technical skills, or?
Yeah. So as I mentioned before, and going through these components, you'll notice there's a lot of different things. So from the material science of carbon fiber to all the electronics and the software that goes into this, and how those interact is critical to being an engineer in the Air Force. So if you think about a really, really complicated platform like our new jets, you've got a whole bunch of weird sensors that are coming in, just like this, and then that's got to translate into how it flies through the air and how we design those things to interact with each other, which is exactly the same technical principles that we use to design and build these drones. You also notice from the question earlier that we do crash these components a lot. So because we are not only the designer of these drones, but also the maintainer and the operator of them, we consider how it's going to fly and how easy it is to repair. And these are the exact same considerations we need to put into play when we're designing a new piece of kit for Army, Navy, or Air Force, because we want anyone to actually be able to have a look at it and be able to diagnose what's wrong with it and make that as easy as possible so we can get that bit of equipment working again as soon as possible. Hope that helps, Jake.
Yeah, that's awesome. So we've covered sort of military aspects, how it relates to our personal jobs. That's fantastic. How about if we have some students from year 11 and year 12 thinking about some other STEM careers in science, technology, engineering, and maths? Do you think the skills of drone racing or the skills that were presented here today could assist those people?
Yeah, I'll take that.
I believe Luke has a great one for this.
Perfect. So good question for me, I guess. And why I say that is because my uni degree was mechatronics and robotics. It almost speaks for itself, but in reality, what that means is you're not a mechanical engineer, you're not an electronics engineer, and you're not a software engineer, but you're kind of all three. And what my focus was in that mechatronics engineering field, which is a big field, I must say, in the future, you're talking anything robotics, integrated systems, smart systems, and AI. What that degree did for me and what drone racing does in exactly the same manner is it teaches you to look at all the aspects, so those mechanical aspects, materials, it talks about the software, the design, the electronics, and it gives you the ability to, from a system standpoint, put all that together. So if you're not looking for a defence career specifically at the moment, why it's important and why it's good to get involved in, it means when you go to that university degree and you get that first job and you start getting that work experience, you're already 10 steps ahead of your peers. It is a competitive world out there, but it's also a lot of fun as well. It means you're going to arrive at that job with, I guess, a really good understanding of how things come together, and not just how they come together individually, but also how do I take a product, being a drone, get it in the air, get it through regulations, do it safely, make it work, and as cheap as you can. So there's so many, I guess, system level learnings, and there's so many things that I guess you could use a good word called transferable to other parts of industry as well.
That's great. Thanks for answering that question, Luke.
Cool.
We also have another quick follow-up question from Melanie. Can you fly drones in rain and snow?
I'm happy to field that
Yes.
one. 'Cause it's actually something that I'm working on at the moment. So snow, yes, because when the snow falls, it's actually not big of a deal as long as it doesn't get caught in the components here. So you can see this canopy on the top there. It's really good for keeping that kind of stuff. Rain, no, without modification. So all of these electronics are very, very bare. There's no waterproofing on them at all. But what we can do is we can coat them in something called conformal coating. So it's quite similar to clear nail polish, and puts a protective barrier over the top of all of electronics, so none of it actually breaks if it is in the rain. And I'm actually about to start doing that now because I want to be able to fly whenever I can, whenever I've got the opportunity to do so. And so I'm going to coat all of these in this clear nail polish type substance so you can actually fly in torrential rain. There's even been cases of people dropping them into a river and it's still actually able to take off again and come back out. But your main issue with the rain is if all that water is in the air, you actually get a lot of signal being lost due to being absorbed by that water as it's flying through. I hope that answers your question. So now that you know exactly how a racing drone is built and what goes into it and how we get this cool tech and apply it to our jobs, we're now going to go into the really, really exciting part, which I'm sure you've been waiting for, is actually flying the drones themselves. So to start off with, so we're just working out some technical difficulties at the moment, but we'll be showing you some live view of some little tiny whip drones that we introduced before, flying around this absolutely awesome location with the background of our C-130J Hercules. And we'll also be showing you the simulator. So the simulator is a really, really powerful tool for us because if we keep crashing these things, it's a little bit expensive, unfortunately. So the simulator lets us try out some new and different movements, as well as getting a feel of how these things actually fly, particularly for those who have never flown them before. So the way we get a lot of our members to start off is actually flying the simulator, so they can get a feel of how these drones fly. So I'll talk a little bit about the performance of them. So I'm sure some of you guys have actually seen or flown drones before. And when you fly your standard drone, you push the stick forward and it goes on an angle and then it returns to level. As I alluded to before, the only stabilization that this drone is going to do for us is hold that last angle. So we could be upside down, on the side, whatever direction, and it will hold that angle for us. And that's the only stabilization. When we push the stick forward on your standard drone, when you push it forward, it just goes to an angle. What the sticks actually control with us is how quickly that drone rotates. And basically how quickly it turns, and that's what we use to fly. And this may seem a bit counterintuitive because it sounds like it's really, really difficult to fly. And we're now, but it makes us able to do some really, really cool movements. So we'll now hand over to the simulator feed. Hopefully we can get someone up flying in a second. And what you'll see is two little boxes, and that is actually showing the position of the sticks.
So we're just currently getting the simulator ready. And as always with drone racing, there's always technical issues. As you can see, this is just it's a program called Velocidrone, about $20. Just Google Velocidrone if you want to have a turn of that. We'll now switch over to the HD feed of that. And we can see our pilot Luke isn't too great right now. The pressure of flying with a massive audience as we have here today has gotten to him. But anyway, here we go. You can see this is pretty much exactly what it looks like when you're flying around. Given that it is a bit dark, we don't usually fly in the dark. And we don't usually have thousands of dollars of neon gates. We just buy cheap material and PVC pipes or pool noodles. That's probably the cheapest way, $2 each from Kmart. Not nah. And just assemble it that way. So I think we'll start a race and see how good he is on this map. So we're switching pilots. Professional pilot Nick. Yes, you do have audio on, and everyone did hear that.
So you'll notice here that it's actually showing us where the gate is. Unfortunately, in real life, we don't get any of that at all, and you just have to know the track really, really well. You also notice how much stick input I'm actually putting in. So those two little squares at the bottom there, that's representative of what my control sticks are doing. And you notice that I'm constantly adjusting them, and it's actually really, really hands-on. I'm struggling to talk at the moment because I'm trying to concentrate. You notice there's a lot of input. Unlike some other drones that you might have been able to fly, if I let the sticks go at any point, this will probably crash within about 5 seconds, which is only slightly better than when I'm in control of it, which takes about 10 seconds for it to crash. The really, really good thing about the simulator, as I mentioned, that when I do crash, I just hit F to reset, and I can get back up in the air again.
That's great. While Nick is flying around, we'll get some actual drones flying in the background. So do we have our pilots? We'll switch over to my cam for a second. Yeah, we have our pilots just behind me. They're keen to fly. I can't stop them. They're going to force me.
So, whilst they're setting up, I'll show you a few common obstacles. So you'll notice that there's these big poles here that I'm flying around. That's what we call flags, and then these here are gates, and that's basically what we usually use to actually fly around as our obstacles. Some other ones you might have seen, and I'll just double back to look at it, is what we call a dive gate. So you have to go up and then through, and this is actually quite a difficult maneuver to master, and we're really grateful for having the simulator for that. Some other movements that we might have is what we call a corkscrew. So we have to go up, around, and loop through like that. And again, this is just some common obstacles. And once you master these sort of basic obstacles, you actually tend to get muscle memory. And so you're not really thinking about what you need to do to achieve it, just that, oh, okay, I need to loop around the back here and then go through.
Sweet, that's great, Nick. We also have another question. How can I get involved with drone racing?
Great question. The best way is to start off on either a simulator by getting yourself a transmitter, or one of those tiny whoops that Luke alluded to earlier. And then you want to get in contact with your local drone racing club. So if you just type in whatever area you're in, followed by FPV racing, first person view racing, I'm sure a club will pop up on Facebook or Google. And you want to have a chat to them about what the latest and greatest tech is, and then go onto an online supplier and get ready to start building your first drone. YouTube and Google are your best friend with this, as they'll provide all the tutorials. Alternatively, you can contact the Army drone racing team on their Facebook page for any other questions that you might have.
That's great, Nick.
Add to that, if I can. I'll just add on to that if I can. So I guess, so it's Luke back again. So the way I got into this is obviously I teamed up with the other colleagues. So Nick, Jake started racing primarily on the simulator. So what you're seeing now, what you're seeing Nick fly, it's a Steam game. I think it's about $20 or $30. Is that right? About $30.
$30.
You get something like that downloaded. You get a brand new or second-hand transmitter for about $150 to $300, depending on how much you want to spend. And at that point in time, you can fly. You can learn how to fly in our race mode. You can keep going on until pretty much you run out of breath and you have enough. I guess when you're flying, like when you're learning how not to crash, that's the point in time when you can actually go back to the bank account and start ordering in some small quads. Once you get your small little tiny whoop quad, I'd strongly advise you fly that inside for a bit, and then maybe take it down to your local park or somewhere where you're legally able to fly, and then progress up. So it's really just an incremental, start small, spend very little. Don't spend too much money at the start because you don't want to regret spending it if you don't continue on with the hobby. Once you get good, spend more money, buy better stuff, and start racing more seriously.
That's great. Thanks for that, Luke. I also will add a tiny bit to that. So Velocity drone, it's great, but you need a controller. I actually don't have one on me. RC controller. If you have one in the house, that's fantastic. Just plug it in through the USB point and off you go. The only thing is, probably not everyone actually has a FR Sky radio controller. So what do you do then? I'm pretty sure most people have an Xbox controller, right? A couple of joysticks there. It looks about the same. Or PlayStation controller. So it's actually pretty cool. Following a couple of online tutorials, quick Google search away, you can actually connect those controllers up, and it's not the exact same as a full RC controller, but it's pretty close, and it will get you the taste and feel of what drone racing is all about. So definitely that's a cheapest alternative, and there are a couple of free drone racing programs out there that you can get. So we'll get some. We're going to try to set up the video feed from the pilots which are flying around right now. So I'll just hand back over to Nick to chat for a second while I'll adjust the HDMI feed.
So the other awesome bit about the simulator is that you can actually design the tracks yourself. So this one was designed by someone in New Zealand. And so what you can do if a track gets released before race day or before a major event, you can try it out and then try different things. So I've taken that gate like that. I might want to go something a bit different and go a bit higher so I can pick up a bit more speed and see if that works. And because it's recording your lap times, you can see which one's better and which one you feel more comfortable with. The other awesome one with the simulator is that you can actually put some really funky obstacles in that you might not be able to build in real life. So this was particularly good when we hosted our recent online military international drone racing tournament, where we competed with guys from New Zealand and the UK. We were able to actually fly right up a mountain and over a volcano in the simulator, which was really, really fun to do, and fly around aircraft, which obviously you can't do in real life. In the simulator, sky's your limit.
That's awesome. Thanks for that, Nick. We actually have a feed of the cameras right now. Just because of a couple of issues with this design of drone, believe it or not, you get a lot of white flickering on the screen. So the pilot sees a better image than what you're seeing right now. It's not as washed out and as flickery, but it's still quite low resolution. We'll get that pilot to fly a bit closer to that receiver over here, just near my desk. Oh, I think he's crashed. Oh, yep. If we can change his battery out. He's just replacing his battery. So, yeah, so this gives you a first, I guess, an FPV view of your flying around. And we're pretty lucky here, flying around some C-130J fuselage trainers. Oh, here we go. The pilot's video is back up. And off we go. Flying around. There's a forklift there. This is not my normal work environment, so I don't know much in the building here, other than there's a big plane. Yeah, if we get that drone a bit closer over here, the one I just, yeah, that's one. Yeah, fly towards me. See if you can hit me in the head. These are pretty small, and whoa, that's closer. So, no, they're real fun to just fly around, especially chase around the pets at the house. That's one of my favorite. They love it too. If they can catch it, oh, it's a great chew toy for them as well. So I think we have another pilot, Luke. I'm just going to change over to his channel, and I'll be back in a second.
As I mentioned before, you'll notice that there's some figures that's on the screen there. So I'll talk through a bit about what they are. So in the bottom left, you see a little R, a 4, and a 25. So what this corresponds to is the frequency and how much power we're actually putting out. R being race band, and then the 4 being channel 4, and then the 25 being 25 milliwatts. And then you can see this one completely different. So top right corner, you've got what your battery voltage is, which tells us how much time we've got still left to fly. You've also got which mode it's flying in the bottom right. And in the middle there, Modular 7, that's what the drone's called. We've also got on the top left, how much signal there is. So that's that 66 value. That's corresponding to how much, how strong the signal is that the receiver is actually getting in. And then you'll notice bottom left, the MAH, that is milliamp hours. So that's basically how much current we've actually drawn out of the battery so far. So all of that information is completely customizable, and each pilot will put their own thing. So you would have noticed before that there was Tomahawk down the bottom as a name. Each of us have our pilot name. So in the same way that you might have a name if you play NBA 2K20 or any of those kind of games, we've also got our own names for pilots as well, and that's usually what gets called out. Now, the other really interesting thing is when we're racing around, we need a way of actually being able to tell when the drone crosses the start-finish line. And so we could either put a little transponder or something on there to be able to detect this, or all of the drones are putting out a video signal. And so what we do is we look at when this video signal actually goes through a gate, and that's what we use for timing and determining positions. The downside to this is if the drones are really, really close together, sometimes it can be quite difficult, and we often have a webcam there just to separate those 0.1 milliseconds or 0.01 seconds that races often come to. I've seen a lot of races that actually come to the point where we have to go frame by frame to see who actually crossed the start-finish line first. The other funny one is when you get some videos of people crashing and just rolling through the start-finish line. You do actually have to have your video on to be able to register across the start-finish line, and that's part of the rules of it. So you can see here that the video is actually a little bit better now that we're closer, but the further away we get, the more signal that's bounced around off each other, and also the less signal that's actually being received on our end. So you can see in that top left corner, we're sitting at about 70 to 80, which is really good for how close it is. But when he was going through the Hercules before, then you would have noticed that it dropped down a bit. And we want to be constantly monitoring that so that we don't suddenly drop out of the sky for no apparent reason, which can happen. So when these things are flying around at 100 k's an hour around a race course, we don't want to lose control of them at any point. So if that signal drops below 40%, then the drone just drops straight out of the sky. And this is one of the safety considerations that we put in place so that we're able to do this quite safely. Now, it's not too big of a deal when we're flying these tiny little ones in here, because if that hits you, then it's not going to do any damage. It only weighs about 30 grams. It can only do about 40 kilometers an hour. So not a really big deal, but one of those big size racing drones, unshrouded propellers going at 150 kilometers an hour and weighing 500 grams, that's going to do a bit of damage. So we want to be able to disable that drone as quickly as possible. So you would have noticed our highly skilled pilot there is hovering in front. You'll notice it's actually quite difficult to stay level like that because it has no idea the drone has no idea where it is in space. So our pilot is constantly putting in feed, and you'll notice the concentration on Luke's face there, constantly putting in adjustments to try and be able to get it to hover. And this is where it differs from some other drones you might have seen before, because it doesn't stabilize very well, which is really, really good when we want to fly with great agility, but not great when we're just trying to hover like this. So often we don't hover like this. We fly around at 80 k's an hour without doing much hovering. I'll hand back over to...
Awesome. I'll chuck my headphones back on so I can hear everyone. So we'll just ignore what everyone just saw on that screen there, because Luke did not hit that aircraft at all, did he? Luckily, it's a fuselage trainer and we can actually hit it here and there. And these are really small drones, so, no big deal at the end of the day. So we have some very nice footage there from our cameraman, Alex. It's really hard to track these things with a camera, so very impressive job, Alex. I was checking for any final questions. If I'm looking at purchasing my first drone, what should I look for? Okay, what should you look for? Really key, get in contact with some other drone racing pilots out there. Great way, like Nick said before, you get in contact with your local club. They'll be able to guide you in the right direction. But another key thing is look up those YouTube videos. Parents might say, hey, get off YouTube, you're watching too much, it's polluting your brain. Well, guess what? YouTube is a fantastic resource to extend your knowledge and to learn more about drone racing. Just type in racing drones, how to start, how to build, and there's some great demos out there, many hours long if you want to tune in for that long, or some quick 20-minute summaries. But there's some great Australian shops. For example, Next FPV, Phaser FPV. They have the Sydney-based ones. We also have Metro Hobbies in Melbourne as well. Buzz FPV up in Darwin, I think. Trying to think of a Brizzy store. Can't think of the top of my head. But yeah, there's definitely some great FPV stores. And like we were talking about before, we need some key components, right? So you need your flight controller, you need your ESC, and that's what these YouTube videos will be able to tell you in more detail. The great thing is with these tiny whoops or tiny hawks that we're flying right now, especially that white one in the field of view, you can just buy it as is. It's great, right? So a whole kit with goggles, a controller, and the little drone and a couple of batteries, $250. What you need to search for, it's Tiny Hawk RTF kit, and you just need to make sure it comes with everything that I just listed off there. And this thing, great to fly around the house, zero effort to set up, it's just plug and play and off you go. Now, it is a bit challenging to start at first, and that's why we always recommend try out that simulator. Simulator's great. It saves you heaps of time banging your head across the table, just, why isn't my drone working? And, you know, just flying a simulator gets you, I would say 90% there, right? You have the hand-eye coordination, and it's just that last 10% that getting a real drone really you just need to, you know, suck it up and off you go. But, you know, no, it's 100% great. I would recommend the sport to anyone. And at the end of the day, if you have any questions, do we have any more questions for this? Okay, I believe we have one more question coming in. Just waiting for it to be typed. But I guess summarizing the points I was just making. Tiny Hawk RTF kit, make sure it comes with a controller, the goggles, and the drone itself. And you can be flying around just like our pilots after a couple hours on the simulator. And a couple of fun flights hitting walls around the house. But these are nice and light. Propellers aren't shrouded, so there's no chance of anyone getting hurt. There are some safety considerations for our larger drones, as we were demoing before. The ones about an A4 sheet of paper, they go real quick, and they're definitely only for outside. Hence why we have these little ones flying inside here today. Those outdoor ones as such, definitely make sure you're 100% confident on what's happening. And if you're ever confused about anything related to that stuff, just talk to your local club to make sure that everything you're doing is nice and safe. Again, YouTube, great way. Type racing drone safety, and there's some great tutorials out there as well. Just checking for questions. I think we'll be wrapping up shortly. Just looking for our other pilot, Nick. Nick, would you like to add anything further to our stream at the moment? No? All good? Any other pilots? Do you have anything else to add? That's fantastic. Just get confirmation from... Sorry, I'm just reading the question here. Yes, I've seen the Army and Air Force drone racing teams at some events before. Will there be any public events after COVID restrictions ease? Yes, so we're currently in a restrictions phase, so we can't do many events at the moment. We can only do live stream events like we're showing you here today while maintaining social distance. That's quite hard when we have to do that in front of a public. And, you know, we can't have more than 10 people at a time for any such activity. But as soon as these COVID restrictions ease and it's safe for us to engage during these large public demos, such as the Edinburgh Air Show at the end of the year, Avalon Air Show next year, potentially NYSF for the next forum in 2021, and multiple other venues. Yeah, 100% we're going to get back out there. We have our great trailer now that you would have seen with a whole workbench. You'll be able to walk through that, get hands-on building this stuff. So that's what we're trying to do here. Get everyone exposed to drone racing and see the cool technology that they can do real easily too. Like it takes a bit of knowledge, but that knowledge is so key for your future STEM careers. So 100% we'll be doing public events after the COVID restrictions ease, and it's safe for us to do so. Okay, is there any real racing happening today? No, so we can't actually fly outside at the moment due to the live stream. technical limitations, but we are flying around the Tiny Hawks, and they feel identical to the full-size racing drones. The only difference is a bit slower, but the feel and how they handle in air is actually identical. And that's great about that. They also run the same software and everything, so you start on those little ones, you'll easily graduate up to the more complex and bigger drones. Awesome. We also have the Military International Drone Racing Tournament in 2021, potentially in June. So that's where we get all the military teams across the world, military drone racing teams across the world, and actually race against each other. Back in 2018, which was the first one that was held, it was a fantastic event. Had great fun with other pilots, heaps of knowledge that was shared between us, and it's great to interact with our international counterparts. So we're super keen to get back into those larger events, and definitely an international drone racing tournament in 2021. We'll definitely be posting a lot of stuff about that coming up to that event, and we'll definitely be live streaming the entire thing, so no one will be missing out on that. Potentially in Brisbane, not too sure yet, so stay tuned for that. Awesome, just checking for any final questions before we end this live stream. I might chuck on, just as we leave, if I can find it, some other videos from our drone racing archives. So I guess if there's no further questions, thank you so much for tuning in today. Hopefully you learned something. Feel free, we'll still be on the comments section for the next few hours. So if you have any other questions, just shoot us a message there. We'll try to answer it as quickly and as best as we can. And yeah, keep safe, keep flying, and happy drone racing.
Goggles down.
Today. If you're in your, how great was that? Thanks to Justin, Nick, Steve, Luke, Jake, and Tomo for bringing that fantastic content to us today. If you're in year 11 and you like what you've seen today, make sure you head to our website and get your application in for our 2021 Year 12 program. You will be able to engage with awesome content like this and meet lots of like-minded people. Thanks for joining us today, and we hope to see you on one of our programs in the future.
Good morning, ladies and gentlemen. We're here at the Australian International Air Show 2019 at Avalon. Here we are with the Air Force, the Army, the Navy, and the New Zealand Defence Force.
We don't play the games they play. It's a brand new day. Hey, oh, yeah. Hey, oh, yeah. Yeah.
We're here at the Military International Drone Racing Tournament, where a whole bunch of different countries have come together to do the first ever international military drone race.
We fly the drones in what we call first-person view, which means there's a live camera on board which is beamed directly into your goggles, so it's as if you're inside of it. So it can be quite exciting as you're flying around the track at up to kind of 90 miles an hour.
We build all our own drones ourselves. We select the components and we solder them all together. We program them through a bunch of different applications on the computer. We actually go through that whole process as well to make sure it flies how we want it to fly.
Drone racers are STEMers. They are interested in science, technology, engineering and maths. They teach themselves how to build drones, how to code, how to solder. They teach themselves aerodynamics and electronics. And they're the kind of kids we want to have a conversation with about maybe considering joining the Australian Defence Force as a career.